Hi, I'm Stephen and welcome to my channel that is all about improving your BMW. Although this particular video could very well help you if you own any diesel car made in the last 20 years or so. Today we're investigating whether it's possible to do a DIY clean of your DPF, your diesel particulate filter, and do it in a completely non-damaging way. And by that I mean non-damaging to the stainless steel housing, non-damaging to the DOC, the diesel oxidation catalyst, if your car has one, and of course non-damaging to the DPF ceramic material as well. I think the trickiest part of the operation will be the DOC, because it is made with the super expensive metal platinum and sometimes palladium as well, which is also super expensive. So we certainly do not want to accidentally remove either of those. The clogging we are trying to remove today to clean out of our DPF is called ash, and it is a mixture of things left over that remain in solid form after the diesel fuel and engine oil are burnt in your engine. The diesel fuel that we use in our cars is now low in sulfur because it is the sulfur in diesel fuel that helps cause the ash that clogs up our DPF. The ash also comes from the compounds in our engine oil that don't burn away completely. Things like zinc, phosphorus and calcium. They form all of these compounds, which collectively are called ash, and is what we need to clean out of our DPF in order to make it work like brand new again. Today's video is not about soot blockages. A blockage in our DPF due to soot is related to a failure of some kind, maybe a failure of the EGR valve, or glow plugs, or a sensor. But a blockage due to ash is usually because the DPF has reached the end of its service life, and your car will tell you that by way of an error code. Today you're going to see that this doesn't mean that you need to buy a new DPF, because they all can be cleaned. I've made a simplified model of the ceramic material that makes up your DPF. A diesel particulate filter is a special kind of filter called a wall flow filter, which has alternate channels deliberately plugged. This means that for gas to travel all the way through the filter, it has to pass through microscopic holes in the wall of the channel. The holes are everywhere in the real filter, but in my simplified model, I've just put a few holes in to give you an idea what's going on. Here we have my model representing two of the ceramic channels in a DPF. The exhaust gases come in here, and they exit in the adjacent channel. The only way for the exhaust gas to do that is by passing through the walls of the channels. You can see I've added a few holes here to represent the microscopic holes in the real thing. The black soot comes in the entrance to this channel. It can't get through the holes in the walls until it is burnt at high temperatures as a result of either passive or active regeneration. When the soot is burnt away, there can be small amounts of this white ash remaining. It can't be burnt away, and it can't fit through the holes either, so it eventually blocks the channel and the holes. When there is too much ash for the DPF to work properly anymore, then it is end of life and needs to be cleaned. So, what chemical can we find to dissolve the ash out of our DPF without dissolving the DPF itself? The ash in our DPF is mostly composed of sulfates, phosphates and oxides of zinc, calcium and magnesium. These are called metal salts, and they all dissolve in acid. A couple of them are what's called amphoteric, which means that they dissolve in alkalis, bases, as well as acids. You see the list there? The two at the bottom, zinc oxide and magnesium sulfate, they both dissolve in acids and bases. So according to that list, it looks like an acid bath is what our DPF needs to get all cleaned up. Okay, not so fast. I've received a bunch of comments and emails about DPF cleaning from you guys and gals, and here are the cleaning methods that I have been told to consider. One person suggested using a certain brand of cola, which is a weak acid. Well, still strong enough to eat away your teeth, but still fairly weak in the scheme of things. Another suggested using brick cleaning acid, which is a super strong acid. Another acid suggestion was acetic acid, which is also called vinegar, so not as strong as brick cleaning acid, but still could be a contender. And then we had some suggestions that are not acids, but instead are bases, alkalis. The first was oven cleaner, which is a fairly strong base with a pH between 11 and 13. There was also baking soda, which is a mild base with a pH of between 8 and 9. And finally, another popular suggestion was drain cleaner, or caustic soda, which is a super strong base made from sodium hydroxide, and that has a pH of 14, right at the end of the scale. So we really have the full range of pH levels going on here with these suggestions. Is it possible to eliminate any of these options? If you remember from a minute or two back, we had a list of compounds that make up the ash, and all but 2 of them will only break down in an acid. So I'm not sure that using a base, an alkali, is the best way to go, because we are only able to attack 2 of the compounds in the ash if we use a product like drain cleaner. There is also a big issue with using drain cleaner, and that is it gets hot when you mix it up. Now the reason that this is an issue is because the ceramic that our DPF is made from is called silicon carbide. Because silicon carbide is a super high temperature ceramic material, it has been studied by NASA, the space agency. What they found is that it's almost completely non-reactive at normal temperatures, which makes it ideal if you want to do some chemical cleaning on it. Super. But, and it's a very big but, when the temperature gets over 100 degrees Celsius, or 212 degrees Fahrenheit, silicon carbide, the ceramic in our DPF, will react with sodium hydroxide, with the drain cleaner. Having our DPF ceramic eaten away is the last thing we want, so we need to make sure that any drain cleaner that we use does not get too hot when we are using it. So there are 2 strikes against using strong alkalis like drain cleaner. The first is that it may not get all of the ash compounds, and the second is that we need to keep the temperature down. But there are other parts of our DPF that can be damaged by chemicals. The most obvious is the stainless steel housing, so we're going to test a range of acids and alkalis to see what happens with that, and you'll get to see that a bit later in this video. The other part that can be damaged by chemicals is the DOC, the diesel oxidation catalyst. DOC started appearing on diesel cars around 2007, and if your car is newer than 2010, then you are pretty much guaranteed to have a DOC sitting inside your DPF housing just before the DPF material. A DOC looks a bit like this model I made. It is a mesh structure made of ceramic material that lets the exhaust gases pass through very easily, so it doesn't do any filtering. But at normal exhaust temperatures it does 3 things. The first is, it reduces oxides of nitrogen, so it lowers pollution directly. The second and third things it does are closely related to each other. If any unburnt diesel fuel hits the DOC, the materials in here cause it to react with oxygen, to burn in other words. That's good because nobody wants to breathe unburnt diesel fuel, of course, but it's also good because the burning of that diesel fuel heats up the DPF and helps it to do what's called passive regeneration. Why I'm mentioning this is because in order for the DOC to do all these great things, it needs to not be eaten away by any cleaning process that we do. So we're going to do some tests on the DOC material. So I ordered some aluminum oxide powder, or you might call it aluminium oxide, if you're in a country that has been influenced by Britain and spells it incorrectly. I also ordered a small piece of super expensive pure platinum wire. I had some trouble getting these 2 materials delivered, so we're going to do a quick jump back in time to earlier today to see why that is. My 2 deliveries got confiscated, they got held up, and I've had to go and explain what it's all about. This is the aluminium oxide powder. I don't really understand why that would cause any concern. Here's the platinum wire, a very, very small little piece of wire. The question I got is, what use do you have for this plutonium? Plutonium? What the? It's not plutonium, it's platinum. PT. It says it on the label, not PU. PT for platinum, PU for plutonium. Not the same at all. And anyway, everyone knows you don't send plutonium in the regular mail. You always use... Anyway, we now have some aluminium oxide, some platinum, and some stainless steel to test with. So let's go play with some dangerous chemicals. So what chemical is going to work best for us? I've stolen 4 plates from the kitchen when no one was looking, and we'll fill them with our chemical cocktails. We have, first of all, our vinegar. We have our mystery liquid, which I'll tell you about at the end of the video. And then we have our nasty chemicals. We have our drain cleaner and our brick cleaning acid here. Whenever you mix acid, always make sure to add the water to the acid, just as you learnt in high school. We'll do a quick test of the pH. You can see the brick cleaning acid is very, very strong, right at number 1. The drain cleaner is right at the other end of the scale. For our vinegar, we have somewhere around a 5. And finally our mystery liquid, it's probably around 8 or so, maybe 9, possibly 10. A bit hard to tell, it's a strange colour, that one. Okay, we'll add our stainless steel pieces. And then our aluminium oxide. That's part of what makes up our DOCs. I'm using powder so it's as reactive as possible. We'll know for certain if it's going to cause us any trouble. And finally, our little pieces of platinum wire. And we'll put those in and see if they react. Platinum is not supposed to be very reactive, but we certainly don't want to have it eaten away in our DOCs. Okay, after 2 minutes, we're getting a bit of discoloration of the stainless steel. But we're also going to add these little scrapings, and this is scrapings of the ash out of a DPF, and you can see in the brick cleaning acid that reacts very, very fast. So our brick cleaning acid is a good candidate, but is it too strong if it's eating our stainless steel just after 2 minutes? Okay, let's add a bit of the DPF ash scrapings to the drain cleaner. And we'll also add a bit of scraping to our mystery liquid and our vinegar as well. Now there's no quick reaction going on here, but hopefully we'll give it a few minutes and we'll see what happens. You can see straight away the vinegar isn't eating it very quickly. So we have 10 minutes later, and even more discoloration of our stainless steel. That's not really the sign I was looking for. We want our stainless steel case to remain intact. Our platinum wire is still down there. I'm not sure how well you can see it on the video, but it's still there on both of these. After 1 hour, even more discoloration. I don't think this brick cleaning acid is doing the best job for our stainless steel. But you can see the aluminium oxide is down there at the bottom of that dish. For the drain cleaner, we also have aluminium oxide is intact, stainless is intact, and our DPF scraping is fully intact, so I'm not sure how useful the drain cleaner is in this. Okay, for these two, for our vinegar and mystery liquid, we have no reactions going on at all. Well, maybe there's a bit of reaction with the scrapings. Okay, after 2 hours, even more discoloration of the stainless steel. It's starting to go very black. The aluminium oxide is still there, and the platinum is intact as well, although it's hiding under the bubbles. For the drain cleaner, there doesn't seem to be any reaction going on at all. You can see the platinum there. It's hiding there, but it's maybe just visible in the video. Yep, our aluminium oxide is still there. Everything is intact on our drain cleaner, so not very reactive, maybe not very useful. We have a little bit of a reaction with the vinegar, but this is nowhere near fast enough. This is 2 hours. We don't want to be cleaning our DPFs for days at a time. Now I think we'll stop the tests right there. I don't think there's any point, but we'll quickly jump to at the 12-hour period and see what's happened just for a bit of fun. The vinegar has eaten the ash scrapings eventually, but left everything else intact, which is great, but it's just a bit slow acting for our purposes, I think. The mystery liquid hasn't dissolved anything at all, so I think this mystery liquid is a bit of a disappointment. I had high hopes, but they're not coming about. And up here, oof, well that's a bit different. Our drain cleaner hasn't reacted with anything, so we'll see if that's a bit useful later. We have our brick cleaning acid and our platinum wire is intact, our aluminium oxide is intact, but our stainless steel, that is completely dead. Well, none of those four proved to be our perfect chemical at all. I had high hopes for the mystery liquid, as it was quite expensive to buy, but it didn't seem to do anything useful. You might be quite surprised to hear what that mystery liquid is, and I'll let you know right at the end of this video. The acetic acid, the vinegar, turned out to be just not strong enough to do anything in a useful time frame. It may clean out your DPF eventually, but it might take a week or more to do that, and nobody has time for that. I suspect your favourite cola brand will be the same, just too slow. The drain cleaner, or the sodium hydroxide, or the caustic soda, it didn't react with our DPF housing or the DOC materials, which is good, but it also didn't want to react with the scrapings of ash that I added either. So maybe it's not the perfect chemical, but later in this video we'll see that it has another important use. The brick cleaning acid, or hydrochloric acid, didn't react with the aluminium oxide or platinum that are in the DOC, the diesel oxidation catalyst, but it was very reactive with the ash scrapings, which is what we want. But unfortunately it was also a bit too reactive with the stainless steel that our DPF is housed in. It is not much of a success if we clean our DPF, but afterwards it falls apart. So now we're going to do a second round of tests, using diluted brick cleaning acid, to see if we can get good ash removal, but with no damage to the stainless steel housing, in say 2 hours. Let's get to it. So how strong should the acid be for our test? We've still got our brick acid here, but this time we've watered it down. Always remember to add acid to water and not the other way around. Throwing water at acid can make it do some rather nasty things. So we've got our two concentrations here, a 1/4, 3/4 mix, and now the 50/50 mix. And we'll see if that does what we need it to, but without dissolving our stainless steel case. So in with the stainless steel, and we'll also put in some DPF ash scrapings just to see that it's still reactive. Well, I think that's reactive. And of course this one should be even more reactive, and so it is. After 30 minutes, we have a bit of discoloration in the half-half mix. So maybe that's a bit strong. Our 1/4, 3/4 mix is looking a bit more savoury. After 1 hour, there's a lot of discoloration going on, which means that our stainless steel is being attacked. So I think we're going to end this test here and go and conclude that the half-half mix is still too strong. We don't want to do any damage to our stainless steel case if we can avoid it. Okay, we've taken away the strong mix and just left the 1/4, 3/4 mix. Now we'll add to that some oily soot that's removed from a DPF. Because what we want out of our DPF clean is also to remove any soot, oily soot that happens to be in there. We want to make sure that our cleaning solution, our acid, can get into all of the places, and we don't want it to be blocked by any soot. Now you can see straight away there's no reaction going on there at all. So this is going to potentially be a bit of a problem. No matter how much I mix it, there doesn't seem to be anything going on. It looks like our 25%, 75% mix is going to be quite good at dissolving the ash, but it will also give us a couple of hours of cleaning time before it starts eating away at the stainless steel. But we have one remaining issue, and that is our acid mix has absolutely no effect on the oily soot that can be found in the DPF. So you can imagine a situation where there is a bunch of oily soot that could stop the acid mix getting to some of the ash that we want to remove. And that means we need to use a second chemical that will remove oil. We could use a strong degreaser to do that, but since we already have some drain cleaner here, we'll give that a try to make sure that it will dissolve the oil in the oily soot. Let's give it a try. Okay, let's clean that oily soot. So we'll add back our tray of drain cleaner, of caustic soda, mix it up, and see if it can do something useful to this oily soot that we have. Okay, let's drop a few pieces in there. And give them a bit of a mix. Okay, that's encouraging. We have a little bit of dissolving straight away, and after 15 minutes it's definitely getting to that oil. So I think we've got a good product here for dissolving the oil. I suspect if you've got some strong degreaser, you could mix that up and it would work just as well. After 2 hours, yeah, no problem, it's still dissolving, a bit of agitation, a bit of mixing. I think we have our product here. I don't think we need to continue this test anymore. Let's move on to the next phase. That worked pretty well. The drain cleaner dissolves the oil in the oily soot, so I think it will work just fine for using as a pre-wash, a pre-clean of our DPF. We just need to keep in mind that good research from NASA and not let it get over 100 degrees Celsius or 212 degrees Fahrenheit when we pour it into the DPF. I think we're ready to begin. Let's give this drain cleaner pre-wash a go. We'll start by mixing up our drain cleaner, add a bit of water to the bucket, and then put in those granules. Now don't mix too much at a time, this stuff can get very, very hot, and if we get it over 100 degrees, we've seen from the NASA study that it will do damage to our DPF, so we don't want that, and I suspect if we get it over 200 degrees, we'll melt right through our bucket as well. No problem, not too warm. We don't need it super concentrated to get rid of the oil. As you can see, I'm dressed for the occasion, so when I get chemicals on this particular soot, it's not much of a problem. It's already had a hard life. Shake it, shake it. Okay, let's wash out our sodium hydroxide, our drain cleaner, and see what we get. Now there seems to be a lot of red liquid coming out of this, and that's our dissolved ash from our filter. I really wasn't expecting that much ash to come out as a result of the drain cleaner, because in our test it didn't react very much at all. So it could be with enough shaking and enough drain cleaner, that could be enough to clean a DPF. You can look at the residue in the bottom there, that's a good amount. Okay, I'm wondering why the drain cleaner worked a lot better than initial tests showed that it would. And this is my thinking. It does dissolve some of the compounds in the ash, as well as any oily residue, and this might be enough to displace the rest of the ash eventually, along with a bit of shaking and washing. It warrants further investigation at another time. Let's get back to stage 2 of the cleaning. And now for the acid wash. Now we need to be very protected. Wear all the protection you can find. Get some proper gloves that won't get eaten away by the acid, and some clothing that you don't mind getting some acid on. It's not super strong acid anymore. It's 75% water in this case, and remember, always add the acid to the water to avoid it splashing up violently. Now in goes the DPF into the acid. We'll try and get it to go in the end. In case you're wondering, this isn't a BMW DPF. It's from a Volvo. Don't tell anyone, please. But they work the same. And this came from my friend's car. The mechanic took it out, said it was blocked, and sold him a new one. But fortunately he talked to me in time to go and pick up the old one before it was perhaps thrown away. Now you can see straight away that we're getting more of the red ash residue out of this DPF. Oh, nasty. Acid is a bit slippery. So now I have broken glass as well as everything else. I know how to have fun. The hard part with this exercise is getting it to go in nicely and stay in there. As you can see, I've left one of the sensor holes open, and I plug that very soon so that the acid stays in there a bit more. If I was doing this day in and day out, I'd work out a way to not have to bathe the whole thing in there. But here we are after another 10 minutes. It's soaking away. We want some agitation and some soaking to get that ash right out of the end of the channels. I'm constantly paranoid that I am getting the acid through my gloves. So I end up using 3 pairs of gloves in this exercise. Now I've discovered the perfect position for this DPF so that I can fill it up completely with acid. And the pressure sensor tubes at the top, they let the air out, so this can be completely filled, which makes me happy. Look at that lovely ash residue coming out. Wonderful. This DPF is going to be like new again. And let's fill it up again. Another 15 minutes soak time. Some nice gentle rocking. Keep that acid moving, just in case it hasn't got to every last place inside. Because you're dealing with acid, always wear protective glasses and gloves and clothing. Really, this is the least fun job I think I've ever done on a car part. Okay, 30 minutes of soak time. Look at that beautiful ash residue coming out there. We want to make sure that we get all of the acid and red ash residue out of the filter. So lots of flushing and back flushing should be done. Okay, it's rinsing time. Clean the inside, the outside, put water through, flush it forward, flush it backwards. We want no residue left in this. Yep, let's get some squirting going on there. Perfect. You can see it going in one end, coming out the other. Just what we want. All up, I spent about 15 minutes doing this wash, so you really want to make sure there's no red coming out after we've finished. We want all of that ash residue to be gone. The less that's in there, the cleaner our filter is. The acid has loosened it all, and the drain cleaner as well. We'll just make sure that the water washes it all away. I'm not entirely sure the grass underneath here is going to be too happy with a bit of acid washed on it, but I tried to take most of it into the container. And just when you think you're finished, wash it some more. It's a good idea to let your DPF stand and dry out for a couple of days before you put it back in the car. If that isn't practical, then heat it up as best you can to help any water inside to evaporate off. A heat gun can work well enough. When you do put it back in the car, let your car idle for 5 minutes so that the DPF comes up to temperature slowly, so that if there's still some trapped water inside, there is less chance of it boiling off too quickly and potentially causing damage. I believe that this is the best possible DPF cleaning method, even though I know that spending 2 hours as well as handling dangerous chemicals is not really for everyone. And on top of that, doing it yourself does not give you a multi-year written guarantee like you would get from a reputable DPF cleaning company. Regardless, I still believe it is the best method, The first stage, using drain cleaner, helps remove any oily soot, and it also starts dissolving some of the compounds in the ash deposits. The second stage really makes sure that no ash deposits can hide, even at the end of the ceramic channels. From now on, I'm going to name this the Stephen B. Tuner DPF cleaning method.
Whatever.
We've shown that the chemicals we've used today do not destroy the DOC or any other part of the DPF. So of course the process can be used safely whether your car has a DOC or whether it doesn't have a DOC in front of its DPF. I promised you earlier that I would tell you what the mystery liquid was, and the answer is it's a commercial DPF cleaning liquid, and as best I can tell it is pretty much just a very strong degreaser. Interesting. We'll ponder on whether that can possibly work, but we'll do that another day. Until next time.